In today's tutorial we will have a look at important CO2 derivatives. Here we have the molecular structure of carbon dioxide, and as you certainly know, it has linear geometry. If we press this into water, then in equilibrium water will be added and we will have this structure. This is carbonic acid. So, if we add an alcohol, then we would get to the monoester of the carbonic acid. And if we add an amine to carbon dioxide, then in equilibrium such an monoamide of the carbonic acid will be formed. These three structures I have put into circles. These structures are not stable. If you heat those up, they always will lose CO2 instantaneously. The other structures are rather stable compounds. If you form somehow a monoimine of CO2, then you have an isocyanate, and isocyanates are very important for the synthesis of certain polymers, polyurethanes. Then a double imine, here it's carbodiimide, and this is important in preparative organic chemistry. For instance, forming amides from carboxylic acids and primary and secondary amines. Here, well, this kind of structure can be formed by the addition of an primary amine to an isocyanate, and these structures are called urea derivatives. If you add an alcohol to isocyanate, then you would get to this structure a monoamide and a monoester of the carbonic acid. These structures are called urethanes or carbamates. If you have a double ester of carbonic acid, then you call that carbonate esters. And here we have a special case. This structure, a carbonyl group with two chlorines sitting here. This is then a double acid chloride of carbonic acid. This is the famous and infamous phosgene. Very dangerous compound, but very useful, for instance, for the synthesis of isocyanate. Directly primary amines with phosgene under special reaction conditions will give these important isocyanates. Thanks for listening.